All right, I am fully aware of the fact that the microphone keeps cutting in and out. And so hopefully this one will work. Otherwise, we'll just keep trying to figure it out. Anyway, all right, so we're going to involve some trig and some other stuff. So right now I've got 5 cosine x plus 6 sine x. So one of the tricks is when we were differentiating, you could look at it like this. Okay, so if I took a derivative, the derivative of sine is cosine, the derivative of cosine is negative sine, the derivative of negative sine is negative cosine, and the derivative of negative cosine is sine. Okay, so it would go down or decrease. Well, if you're integrating, it will increase. And the whole thing is, it's kind of a little bit difficult to keep track of your sign changes. So another thing is you've got your handy dandy sheet. So if you will notice, the integral of sine is negative cosine, because before you took a derivative to get an answer of sine, what did it have to be? It had to be negative cosine. So in other words, here we go. I've got 5 cosine. So what is the integral of cosine? The integral of cosine is sine. So I've got 5 sine x. And then what is the integral of sine? The integral of sine is negative cosine. So negative 6 cosine x plus c. Okay. Theta, remember theta is just a variable. It's just like x, it's just like y, it's just another way to write it. So consider this as an x to the 4th. Don't get upset that it says theta. So increase your exponent by 1, and then divide by your new exponent. And then what was secant squared before I took a derivative? Well, the derivative of tangent is secant squared. So if you'll look here, you'll see secant squared. His integral is tangent, okay? So that will become plus tangent theta plus c. And now again, what is the integral of secant squared? The integral of secant squared is tangent. And we're in terms of y this time. And then what is the integral of secant tangent? So I'm looking for one. All right, so the integral of secant tangent is secant. What I'm trying to find is an example where it's not on the bottom. Remember that these can work backwards as well. So when I differentiated tangent, I got secant squared. Well, if I integrate secant squared, I'll get tangent. So there's actually more formulas built into this formula sheet than what's apparent at first. So the integral of secant tangent is secant. And so I have, so negative secant, and then plus c. So now what I want to do is I want to resolve the plus c. So this is what's called an initial condition. So if you have an initial condition, it means that your plus c is going to get fixed at the end. So I'm going to start this thing the way I have before. So again, if I integrate both sides, the integral of the derivative of this function will be the original function. Okay, and then I have the integral of 10s. So the integral of 10s is 10s squared over 2. So that gives me 5s squared. The integral of negative 4s to the 3rd is a negative 4s to the 4th over 4. And then I have a plus c. Well, what have you got now? If I shove in an s, it will spit out f of s. So, or if I shove in an x, it'll spit out a y. If I shove in a whatever. Okay, so this is your independent variable. This is your dependent variable. So I can figure out what my plus c is. At this point, I know that f of s equals this, which is called the general solution. Well, if I have an initial condition, I can figure out what that plus c is. So back up for 1 second. What does that plus c do? That's going to raise and lower the graph on the axis. Okay, so what is addition or subtraction of a constant when you're graphing will raise it up or lower it on the graph itself. So I'm going to resolve this thing. So if I shove in a 3, I'll get a 7. So if I shove in a 3 minus, oh my goodness, this is a big number, I'll get a 7. So I have 3 squared is 9. That gives me, I have to move over here. 9 times 5 is 45. And then minus 81 plus C. So I'm going to add 81, which is going to give me 88 equals 45 plus C. And then I'm going to subtract 45. So when I subtract 45, I will get 43. So 43 is C. So your final answer for your particular solution is going to be, instead of plus C, you're going to have plus 43. So you figured out what that value is for C. So now let's do it again. But we got to do it a couple times this time. I'm given the second derivative. So when I integrate, I can use information from the first derivative to resolve my plus C. And then I'll integrate again to get the final general, or the final particular solution. So the first one is, if I have the second derivative in terms of x, and that's 4. Okay, so when I integrate both sides, I'm going to get my first derivative is 4x plus c. Well, now I have some initial conditions to resolve. If I evaluate at 2, I'll get a 12. So 12 equals 4 times 2 plus c. So c must be 4, because I subtract 8 from both sides. Okay. So now I have my first derivative, you can't see, in terms of x, is actually 4x plus 4. Well, now I can integrate both sides again. And so I find out my original equation is 4x squared over 2, which is 2x squared, plus 4x plus c. And now I can resolve that one. So if I evaluate at 2, I'll get a 17. So 17 equals 2 times 2 squared plus 4 times 2 plus c. So 17 equals 8 plus 8 is 16. And so 1 must be c. So your final answer is 2x squared plus 4x plus 1. So 2x squared plus 4x plus 1. And then the final one on this section is we're going to travel to an evergreen nursery. So when I go to the evergreen nursery, it sells a certain shrub after 7 years of growth and shaping. The growth rate during those 7 years is approximated by dH/dt. So I'm going to write this down here. dH/dt is 1.2t plus 9. Okay. T is the time in years, and h is your height in centimeters. So what this is saying is, how is the height changing as time changes? Okay. So the seedlings are 16 centimeters tall when planted. So you know that when they are planted, or when t is 0, they are 16 centimeters tall. So you are given an initial condition where this is t and this is h. So multiply both sides by dt. So dh equals 1.2t plus 9 dt. Integrate both sides. So the integral of 1 dh is h. 1.2t squared over 2 is 0.6t squared, sorry. And then plus 9t plus c. So now I can figure out what c is. So if t is 0, h is 16. So if I zero out this term, and if I zero out this term, well then h must be 16, which means c is 16. So I know that my particular solution is this, because I substituted in a 0 here, which means your height had to have been 16. Okay, so then it says, how tall are the shrubs when they are sold? Well, after 7 years of growth and shaping, I can find out the height by substituting in a 7 here. So the height after 7 years will be 0.6 times 49, plus 9 times 7 is 63, plus 16, and then I'm going to let you do that on your own, and that'll be your height. All right, so hopefully the microphone works better. I guess we'll find out soon.